Okay, ladies and gentlemen, students and educators, a warm welcome to our mathematics webinar today. We are delighted to have you all join us as we explore the world of numbers, patterns, and problem solving. Throughout this session, we will unravel the beauty of mathematics and its practical applications in our everyday lives. Whether you are a math enthusiast or just curious to learn more, this webinar promises to be an engaging and informative journey. So let's dive in, explore, understand by unlearning and learning, and together discover the wonders of mathematics. Thank you again for being here. Please save your questions, if any, until the end of this presentation, and kindly use the chat option to post questions, if any. All right, let's dive in. So where are you right now? So in a nutshell, I would say you're at the one-stop solution to all of your mathematical problems. And what could that be? So just before the moment of thinking about even creating this free session for all of you, we underwent a poll session. And through that poll session, we were able to attribute scores, ranking, and stack ranking of chapters that are very difficult and challenging for the audience as students to understand in SSC for Telangana state syllabus. And I believe it's not just limited to this particular state, but this is something which is probably common across India and probably also maybe all over the world. But we're not going that high. We're just going to discuss about at state level for this particular session. So where are we? With the poll, we understood and identified that there were certain chapters that students found very difficult and challenging to understand with an easy go. And here we are as Neophytes Educational Institute professors or tutors to help you out equate each and every subject with your real life so that it becomes way too easy for you to understand how things work. Alright, so you are at a one-stop solution for all of your mathematical problems at once. Here you'll not only understand how a particular problem is solved, but you will also understand the entire logic behind every formula that you memorize in schools. Right. Again, before we head into the subject, I would like to give a quick introduction about NEI, that is Neophytes Educational Institute. So whenever I say NEI, it's that. Alright, so what are we? Who are we? We've been in the educational field for the last 20 plus years. We started way back in 1999 in Hyderabad when we had AP government, and we had also educational curriculum supported by the government. So we introduced our educational curriculum to the city of Hyderabad that we carried from KSA all the way to India. And we have gone through a lot of hurdles and a lot of changes in the curriculum, so you can understand that this gives you an understanding that we have all the juice in our hands. Please ignore all the background noises and apologies for that. Okay, so we, with a total educational experience of more than 2 decades, have a highly experienced faculty with us. We just don't hire people at random because for us, educational is core quality, and if that is not delivered to the students in the right shape, in the right form, then we're not taking for responsibility of the student's future in that way. So in order to give perfect surety of your upcoming excellent future, we introduce you to the best foundation that you can ever get in the market, especially of Hyderabad. Our approachability, you can find us easily on Google by typing Neophytes Educational Institute Hyderabad. The first link that you'll see would be us. You can reach us out through the chat support mechanism over there. There are our contact email as addresses. We also have our contact number over there, so you can also reach us out through that. And by the end of this presentation anyway, we will be sharing all the contact information that you would want to have for reaching us out. Our tenure, like I made mention, more than 2 decades, so that would be our tenure. And if we shortline our short-term and long-term visions, we right now are in the process of optimizing as much information as possible for the educational era for all the students that they are going through, that things that they're studying all together, and we are in the process of also building mechanisms that can help students enroll much better with more tendency into technological advancements. Ignore all the background noises. Apologies, because this is totally remote. That's why. All right, if you have any questions in regards to our curriculum, please feel free to drop them in the chat by the end of the session. So about today's webinar, this is the hot topic. So we, from the polls, identified that trigonometry has been highly voted and ranked as one upon all the other mathematical subjects for SSC 10th standard by the students, by you guys, as one of the most challenging chapters that you have ever faced so far. And why is that? How did that happen? And when did that happen? It is only because you haven't seen anything as theta or maybe sine or cosecant or secant, x, y, z's ever before getting into this particular chapter in a rush like it is in the 11th chapter and 12th chapter of your subject. Right. How did you find it? That is like why it is difficult. And the second question would be, how did you realize that it is difficult for you? You only realize that it is way too tough for you to understand trigonometry because you realize that there are so many formulae into it. There are like a lot of identities that you'll have to memorize. There are like a lot of concepts, a lot of mathematics. Anytime you switch to any different formula, for example, if I say cos 2 theta, there is not just one formula, there are like two identities equating with it. So you get confused which one to select, which one to use. And when did you realize that, okay, this is an extreme of a challenge for you to go through? You realize this when you try to break it down, but unfortunately, after multiple attempts, you couldn't do it. So that's why, how, and when for the trigonometry and the poll results that we were able to do research upon. How does this actually help you in real life trigonometry? Well, you know what? It's actually helping you right now. The way that you're looking at your phone, probably if you're attending the session from your phone, and or maybe if you're attending, let's use a laptop or desktop example, sorry. Let's say that you're sitting on a table and you have your desktop screen right in front of you and you're looking at the screen in a straight line. Now let us say that we've lifted the screen from its initial position to a position of a different height. Let's say that you had to tilt your head upwards so that you can look at the screen. You just made an angle with the previous position horizontal line. This angle is what is called theta in trigonometry that we're going to talk about ahead. And you just created a triangle. Did you realize? Position 1 of the screen to position 2. That is one line. From position 2 to your eyes, that is the second line. From your eyes back to the initial position, that is the third line. You just created a triangle yourself. So why triangle? Why am I talking about triangle? We're talking about trigonometry, right? Why is there a triangle here? Triangle is the baseline of trigonometry. The way you cannot live without having a heart is exactly the way trigonometry cannot survive without having a right angle triangle. So any triangle with one of its angle having 90 degrees requires to be in the family of trigonometry, and trigonometry deals with solutions of solving all of these right angle triangles, all such triangles with a 90-degree angle. I hope that makes sense, and I'm going to make it more clear as we move to the whiteboard. Let's go to it right now. Give me a second to switch windows. That's where we see our beautiful whiteboard. Let me open it up real quick, and let's go to the editing mode of it. Alright, so let us say, okay, let's use the same example. Yeah, you were sitting here. This is you. That's your round head. Apologies, that's not how you look. Let's use a rough pen. That is you. Okay, that's your small head, and probably that's how you're sitting. This is the table. Okay, and you're looking at a screen of your laptop, which is over here. Okay, we lifted this screen onto this position. So now you're not looking here anymore. You're not looking in this direction. Instead, you're looking in that direction. So you just made an angle like that with the horizontal imaginary line and the lengthiest line over here, you just made an angle, and now you complete the triangle like this. Let's do this in a little more fairer way. I'm gonna erase everything that we have here, as disgusting as possible. Okay, I'm gonna redraw this entirety in a much more easy and simplified way, probably like that. So now that looks like a triangle. Let me choose a different color. What did you do? You just made an angle here, theta, and here is your opposite side. This is the side that is opposite to you. This was the side which was initially just a table, but it is now called adjacent side of the triangle. The lengthiest side is called the hypotenuse side of the triangle. How am I able to say that this is O and this is A and this is H? I'm only able to say that because it is this opposite side, it is against the angle, the adjacent side is in line with the angle, and the lengthiest side is the leftover side, that is called hypotenuse. So this is what it is. You got the idea, and you look so cool now, you look happy. Okay, right, let's go back to our presentation. What is next? In today's class, what we'll be learning about the sides of a right angle triangle, which I'm sure that we just did, but I can run you guys through again. And we're also going to talk about the ratios in a right angle triangle. What is that? Sounds very crazy and whoa, it scares you, right? No, it is not. It's going to be way too easy. And we're going to probably end this session by discussing about Pythagoras theorem. So let's go back to the whiteboard. Yeah, I'm gonna clean up everything here, or maybe I'll just probably start using the same stuff. Let me go back and select the black pen here. As you can see that this side we call it opposite because it's right in front of the angle over here, whereas this side we call it adjacent because it's below the angle, and this one is hypotenuse, the leftover side. Now you should ask me, why are these, or how are these necessary or utilized in our daily life? So let me help you with a clearer explanation about it. Let us say that you just went to Ocean Park. I believe a lot of people of Hyderabad, they're aware of what Ocean Park is. So for those who are not aware, or for those audience who are not from Hyderabad, Ocean Park is a water park where a lot of kids, even I as a kid, used to go and enjoy with the water slides and all of that. So that's what we're going to use over here. Let us say that this particular thing is this slide. Okay, this is the slide on which you're gonna get on top of it and you're gonna slide all the way into the water. So let me just create that water. I really wonder, there is a blue pen, yeah, there is, and this is the water. Wow, it looks so nice. All right, so now what are we gonna do here is, like, we're gonna use this black marker to indicate that this particular slide which is on the ground needs to be fixed over here from this point to this point. By fixing that, we guarantee that this person, who's you, maybe at Ocean Park, are gonna climb all the way up and then slide all the way down. Right, so in order to lift this slide from this position to that position, we will have to probably give it an angle like this, which would decide that, okay, this particular thing just moved up with an angle theta. I hope that makes sense. So now we just made use of adjacent and which side? Hypotenuse sides. Now let us say that you also want a ladder, because just having the slide fixed on top will not help you climb it up. So you need a ladder which goes all the way straight like that, and then you sit over there and then whee. Right, so this ladder is required from this particular point. So if, let us say that we built a ladder ourselves and we're about to fix it, we need to also know that what angle would be the best for the ladder to be fixed at, because you don't want to make the ladder go slant this way. No, it's best to have the ladder in this way, because you probably will enjoy this more as compared to this. Alright, so the angle, again, let's use a different color. For the ladder, let's use a green color. And now this is also another angle, theta. Are these two thetas equal? No, we don't know that. That's why we will call this one as the second theta, like this, theta 2. Ignore my handwriting. And let's call the very first one as theta 1. So these two are the thetas, and now we can also see that there is a 90-degree angle that has been made between the ground and the ladder. So that's the entirety. What we see here is U. So let us call that U are at point X. Point Y is the end of the ladder, the foot of the ladder, and point Z is from where the slide is originating. Right? And now you can enjoy. You can go all the way up, and then V all the way down, then all the way up, and then all the way down. So this is just a very basic, a very lousy example that we can use for this particular session to discuss about sides of a triangle. Now the second topic was ratios. So let me really quick clear everything that is here, or probably not. Okay, let's continue with the same. Right, I'm gonna choose a pen that is black in color. Ratios. So when you compare the opposite side of, let us just pick up this angle. I'm gonna erase the green angle to avoid confusion. Okay, let's stick to the black angle. Right, now here let us say that you wanted to compare the opposite side with the hypotenuse side so that you get what exactly was this angle. If you want to understand this angle, probably you just want to compare the opposite side with the hypotenuse side. And also if you want to know about this length, you'll compare the adjacent side with the hypotenuse side to get the right angle about it, right? So these comparisons in mathematical terms are called ratios. So when you have the comparison of opposite side with the hypotenuse side, and if you have the comparison of adjacent side by the hypotenuse side, and also if you would want to compare the opposite side with the adjacent side directly and ignore the longest one, these are the comparisons. And in mathematical terms we call them what do you call them from the slide? Do you remember? We call them what? We call them ratios in a right angle triangle. So these are all ratios, and these are allocated to the right angle triangle. Now how and why are these ratios useful, and in what terms? So let me make that more clear by clearing off the entire screen and going back to draw a right angle triangle just the way we did with the black pen. So let's draw a beautiful right angle triangle just like that. And right after that we're gonna pick a pen, we're gonna use a color, we're gonna make this a 90-degree angle. Let us again assume that the angle is over here and it is called theta, and now we have the opposite side to it, the adjacent side to it, and the hypotenuse side to it. Now let us also remember that we gave these things names as x, y, z. What are these things? These are the points of these 3 points of the triangle, right? It is called trigonometry. That means 3-angle measure. That's why we always need to remember that it's only going to deal with trigonometrical triangles that are having 90-degree angle in them, right? Now if we want to compare these sides, and let us say that we already have the answer for opposite, we already have the answer for adjacent, we don't know what the value of hypotenuse is. In order to simplify stuff over here for us to do the calculation part, Mr. Pythagorean, he invented this formula, he discovered this formula to which we can refer to whenever we want to understand or maybe obtain the value of one of the 3 sides if we have already the values of 2 sides. So he introduced this formula that can be remembered using the Hyderabadi approach of saying yes. We say how. At Hyderabad we say how when it comes to saying yes. किधर जा रहे हैं? हाँ उधर ही जा रहा हूँ. हो गया क्या? हाँ हो गया. So you can remember, you can refer to this and just write how, put an equal sign and then a plus sign, and then square each and every term on top. So this is what the Pythagoras theorem is. So let us say that this side, the opposite side, is 3, the adjacent side is 4, and we don't know what the hypotenuse side is, so we do this. H square is equal to under root, oh I'm so sorry, that doesn't take an under root. Let us just put these values as they are. 4 square plus 3 square. So this 4 square becomes 16 plus this 3 square becomes 9. The addition of these two gives an answer of 25. H square would be equal to 25. When you shoot the square on the other side, it becomes a root, and under root 25 becomes 5. So now you have the hypotenuse side too. With this, we just covered all of these three learnings for the day. So now we're also done with the whiteboard stuff. Before I conclude this session, here is how you can contact us. This is the telephone number that you can reach out to for getting information about our sessions and all of these free classes, and for full-time premium subscription as well, you can contact any of these two, the email address or even the phone number, either a direct call or a WhatsApp. And you can also pay an offline physical visit using the address below. Hope this session was fruitful for all of us. See you soon again. Thank you guys. Bye.